हेलो एवरीवन, सो वेलकम बैक टू माय चैनल। मैं एक इलेक्ट्रो टेक्निकल ऑफिसर हूँ, मर्चेंट नेवी में काम करता हूँ टैंकर वेसल पे। और अभी मैंने एक इलेक्ट्रिकल ड्राइंग की जो सीरीज चालू की है उसमें अगला वीडियो आ गया है। इस वीडियो में मैं आपको बहुत ही जो डिमांडेड वीडियो थी, बहुत लोग बोल रहे थे इंजन रूम में जो एक क्रेन होती है उसके सर्किट को एक्सप्लेन करने के लिए। तो आज के वीडियो में मैं यही एक्सप्लेन करने जा रहा हूँ। तो वीडियो देखने के बाद आप लोग कमेंट जरूर करें, क्योंकि मैं जानना चाहता हूँ कितने लोग वीडियो देख रहे हैं और कितने लोगों को ये हेल्प हो रहा है। और इस वीडियो के अंदर मैं 2 सवाल भी पूछने जा रहा हूँ, तो मुझे एटलीस्ट 50 कमेंट्स चाहिए अलग-अलग लोगों से जो पढ़ रहे हैं, ताकि मैं जान सकूँ कि ये वीडियो आप लोगों की हेल्प कर रही है। तो इस क्वेश्चन का आप जवाब दीजिए अपने कमेंट सेक्शन में। So in this video, I am going to discuss the operation of engine room crane, which is a very highly demanded topics, which people have asked me to make a video on its electrical drawing functioning. So first of all, see, I will not be able to share the PDF to you guys, because the entire PDF, these all things are copyrighted items, and I cannot share to anybody without the company's permission or the maker's permission. So I am only using it for the education purpose, teaching you guys. So if you want the circuit, you can just take the screenshot. So this is the page which gives all the parts. There is nomenclature, what are the symbols used, and what are the company maker of that equipment, like main contactor, relay, fuse, all these things. Here is the main power diagram. These 3 motors are given, so you can take a screenshot of this. And next one is control circuit, so you can take the screenshot of this also. I will try to little bit zoom it. Okay, you can take the screenshot of this and this next page. Okay, so this 3 page, this diagram is consist of 3 pages. It looks little bit big, and for the new freshers it might look a little confusing and like, oh, it's very hard circuit to trace. But believe me, if you know the basics of the electrical drawing, if you read line by line, you will understand it easily. Otherwise, I am there to help you guys to understand it. That is why I am making this video. So okay, so let's start with the understanding of this diagram. First, I will start with the power diagram. So engine room crane, it consists of 3 motors. First, the motor 1, it is for the lowering and hoisting of the load. Then motor 2, this is traversing, that means it is the movement from the port to starboard, that means from left to right movement. And then the third motor, which is for forward and aft movement of the load crane. So we have 3 motors in this. So let us first start from the source part, from where the supply is coming. So this is the part where the supply is coming, 3-phase supply is coming. And here we have the main circuit breaker for the crane. So once this is switched on, the 3-phase supply goes to all the 3 motors from here, this line. We have a MCO or MC0, whatever it is. So it is for breaking the connection to all the 3 motors, this part. Okay, so now let's see. First motor supply coming here, 1 2 3 supply. Second motor, 1 2 3. Third, 1 2 3. So we have 3 power circuit going to all the 3 motors. So first I will discuss only this motor, our hoisting and lowering motor. Then we will discuss this part and then this part separately. So first let's start the hoisting and lowering motor, how it works. So there is, see, there we have supply coming from here, 3-phase supply. From here it is comes to this part. We have a inverter here, but it means our hoisting motor, this actually this is working on 2 speeds. That means whenever we want to hoist or lower the load, sometimes we want it to it come down fast, or sometimes we want it to come very slowly if we have a heavy load. So we are using a VFD here, variable frequency drive. If we change the frequency of the supply, we can alter the speed of the motor, as you all know, because if motor speed of the motor depends directly on the frequency. So this is the main part where supply is coming from here. It is going to the motor, and these all parts are the control part, how the relays are activating. That is how up or down operation will take place for the motor. So let's go to the control circuit for the hoisting motor. Okay, so this is the control diagram. So from this side, supply for the control circuit is coming. It is going to the, first of all, transformer. It is stepping down the voltage to the lower level. Also we have a floodlight, like that means wherever we want the crane operation to happen, we need a proper lighting there. So on top of the crane itself, we will be having a floodlight. So this is the floodlight connection, and this is a transformer for the control circuit here. So this is the primary side of the transformer with a fuse, and this is the secondary part of the transformers with fuses there for the protection of the control circuits. Okay, so let's move forward. Now see, we for controlling the full operation of the crane, we will be having a remote switch. Remote switch will be, it will having all the switches, like we want to have a up operation, we want to have a down operation, we want to have a port side operation, starboard, aft, and forward. So we'll having a different push button for the operation of this crane. So after the transformer supply is coming here, and first supply it goes to the control board, this one, and from the return path, this is the return path for the all controlling relays and contacts, everything here. So now let's move forward. We have another supply coming from the transformer, it is going to this unit. So this is RF1, this is rectifier unit. Rectifier purpose is to convert AC to DC. So this DC supply is used for the braking system, electromagnetic brake, because in the crane system, all the three motor is having brake, because it is a fail-safe system. Whenever if any, in case of any emergency, if the power cut happens, the brake should apply and the load should remain where it is. It should not fall down. That is why the crane of the engine room, it is a fail safe system, and it has a electromagnetic brake. So we use DC supply for the braking. Electromagnetic braking is used. So this PNN, we will discuss in details later. Let us now come back to our main control circuit. So from here supplies comes here, it goes to this line. Here we have a EPB, emergency push button, that is for stopping the crane operation in case of emergency. So see, this is now a close contact here, this goes here. Now MC0, this contact, this relay, it is energized now. So once it is energized, this MCO contact, it remains always closed here. So whenever we are pressing this button, emergency push button, MCO gets de-energized, and this MCO contact, this will open, and then the complete control circuit return path, it will open, so none of this operation will take place. So that is a function of this EPB, emergency push button. Now we have a selector switch SS1. This is a selector switch. So this is the switch for switching on and off the control power circuit, this complete path. So once we switch it off, the power supply here, it is gets disconnected, and none of this control supply will work. So when we are selecting the selector switch to on position, this is the on position, this now gets connected. So once we select this complete red line, you can see this part, it gets, it supply comes here, electrical supply, and now we have a MCL relay, it gets energized because its circuit is closed, path is closed. And this MCO, this is already energized, so this path is also closed. So now we got a complete path for the current to flow. Now this MCL gets energized, and MCL will close here. This is the MCL contact here, so this gets closed. So now we have this light L, this gets, this is the indication, source indication lamp, that there is a power in this control path. Now our this line is also gets completed, we have discussed this. Now let's see next line. So now we comes to the operation of the hoisting motor up and down. So this we have push button PBHU. Before that we have SS2, selector switch 2. So this selector switch is for the inching operation of the crane. That means whenever we want to do the very little movement of the crane, we want to do some if our some load is hanging and we are placing it on the main engine, very precision movement is required. That time we will be using this SS2 inching operation. So I will discuss this part later, after we discuss the normal up and down operation. So now let's come to this part, PBHU, push button. This is PB, push button, HU, high up. That means whenever we want to do the operation, when we want to lift the load with high speed, that time we will be closing this switch. This is a push button. So once we close this switch, now let's see, this is the close contact AX0. this is close contact, so our HU gets energized, and this one AXU, this is not energized, so this is a open path, so current will not go here. So once HU get energized, let's see where it is closing. HU, this is the HU contact, so this will close here, so circuit gets completed here, it goes here, goes here, and it energizes MCU1. So till now MCU1 it is not energized, so see, we will trace the path, it goes here, it goes here, and we have a limit switch, it is close, close, close. We have AX15, this is a open contact. So now let's trace where is AX15 relay. Relay AX15 is also energized because this MCU, this is energized, and this path is a closed path. So once this is a closed path, circuit gets completed here, this and this. So this is a closed relay, and now this contact will be made, so AX15. So now you see this path is complete, this path is complete. Now our MCU1, this relay is energized. So once this relay is energized, now come to this part, MCU1. This MCU1, this will be closed, MCU1 is closed, and now this is the inverter part, this will allow the current to pass from here, and our motor will start. In the similar way, once we operate this PBH2 HD push button high down, once we want to operate the crane to down, this line, it comes here, it comes here, and HD, it gets energized, and once this HD energized, this HT, this gets closed, close, close, close. Now MCD1, it gets energized through this path, closed path, all path is closed, so MCD1 is energized. Now we have this MCD1, once this gets closed, motor again it starts in the reverse direction, this is for the up and this is for the down. In the same way, PVLU, this is a low up and low down. Once we press this thing, LU gets energized, in this case LD gets energized, this LU and LD, we have LU, LD, LU here and LD here. So through this path MCU2 gets energized, and through this path MCD2 gets energized. So MCU2, MCD2, we have here MCU2 or and MCD2, it gets energized, and this way motor is operating, this motor. So you all might be thinking, with all this operation motor is operating, but no, motor is not operating, because I told you every motor is having brake system. So see, this motor is, this is the brake, this part is the brake. In for motor 1 we have brake system here, for motor 2, and we have brake system for motor 3. So we have energized the motor, but unless and until we remove the brake, this motor will not operate. So we have to remove the brake also. So how the brake will be removed, I will show you. So this brake, it is always in operation, it is stopping the motor all the times. So whenever we want to operate this motor, whenever we want to lift or lower the load, we want this brake to remove, we want to brake, we don't want the brake. So for that we will be giving supply to electromagnetic coil. Once the supply comes, electromagnetic coil will activate and the brake will come out. So see, so for this electromagnetic coil we need AX2, we want this contact to close. So now we'll see where is AX2 relay. So for brake to remove our AX2 relay, it has to energize, and this AX2 relay will be energized when this AX1 contact will be made, or when we get a supply from your inverter run. So once we get supply from these two parallel path, either any one of them, if any one of them closes this contact, our AX2 will energize. And when AX2, and when this AX1 is energizing, AX1 is here. So whenever we are using MCU2 or MCD2, where is MCU2 and D2? So whenever we are having MCU2, this is the MCU2 and this is MCD2. So whenever this relay is energizing, our brake will operate from here. This relay is energizing, this contact will make either this or this will make, and once this is make, this AX AX1 contact will make and AX2 relay will energize and our brake will open, so our motor will run. And in case whenever we are operating this MC U1 and D1, that time we are getting a signal from here, inverter run signal. This part will get a inverter run signal from here, and this this will close here, and AX2 will close at this point, and AX2 will this will energize and it will open the brake from here. And see, this is a DC 90 volt, from where we are getting P and N. Where is P and N? P and N is this part. I told you that I will be explaining about this later. This rectifier circuit, it is converting AC to DC, and this P and N, it goes to all the three motor. PN is here. We have PN at this point. We have PN here 90 volt DC, and we have PN 90 volt DC. So this supply is coming to all the three electromagnetic brake, all these three brake. Now if you guys notice, this MC U1, U2, D1, D2, all this can be energized from this line also, where there is a parallel line also, TMHU, TMLU, TMHD, TMLD. We have this parallel contacts which can energize all this relay, and it can make the crane motor hoisting and lowering operation. So if you remember this part, I told in the beginning that I will be explaining it after some time why this line is there. See, this line and this line. Okay, so now I'm going to explain why this relay AX3 and AX0 is there. So I will erase all these lines to make you again understand better how these things happen. So you remember about, I told you about the inching operation. That means, so what happens is that whenever we want to do very little movement of the load, either lifting it or lowering it, so we will press it multiple. We will press it here. We will press this button, again we will lift it. Again we will press it, again we will lift it. Again we will press it. So what happens is that this HU, this will get energized, de-energized, energized, de-energized. Similar way, our MCU1 main contact, this is also multiple times it will be energizing and de-energizing. So sometimes it will, what will happen, that contacts, it will get damaged. So what we want to do, we don't want this chattering to happen. We don't want the contacts to on off very frequently. That is why we have a TMHU. We have a TMHU here, here also, here also, here also. TMHU, HD, LU, LDL, different names, but this is a off timer delay. That means whenever we were off timer delay means it will delay the switching off operation. So I will explain first how this is happening. Okay, so we want to do inching operation. So I will select this selector switch. I will switch it on from here. Once this is on, our this AX0 and AX3, it gets energized. Okay, now circuit gets completed. AX0 energized. So once this is energized, this will open and this will close. This will open, this will close, this will open, this will close, this will open, and this will close. So now our now whenever we want to do PBHU, whenever we are pressing this button, our circuit is completing from this part. Now TMHU, it gets completed. Whenever we are pressing PBHD, high down, our circuit is getting completed through this path. Again in this case, it is getting completed in this path. We are getting completed in this path. So now our this HU is not getting energized. HD, LU, LD, it is not getting energized now. So let's take an example. Suppose I am doing PBLD operation. This one, PBLD operation, I am going to do push button low down. That means we want to lower the operation very slowly, low down. Okay, I am pressing this. Okay, then now it gets completed. Circuit gets completed here. Now what is happening is that I am leaving it. I'm pressing the button from here, again I'm leaving it, because I want to check whether my load has gone to the proper position or not. Again within a few seconds, again I will press it. Once this timer relay, it gets energized, TMLD, our circuit gets completed here. MCD energizes. Now I am leaving it. This push button which I have pressed it, I am leaving it. So if I'm leaving it, it will not allow the relay to de-energize at the same moment. It will wait. This timer will have something time about 0 for maybe zero point 0.5 second to 1 second. I don't remember exactly, but less than 1 second. So once I'm leaving this PBLD up button, this TMLD will not de-energize till the time this time has counted. If it is 1 second, it will count for 1 second, and then only this will de-energize. This will open, and then only this TMLD will de-energize, and this only MC-D2 will de-energize. So guys, I have explained the fully operation, that is hoisting and lowering operation of the motor. Now two things are left here in this. We have two limit switch here, as you can see, LSU and LSD. Limit switch for up and limit switch for down. Limit switch up and down button. So this is, as you can notice, this is there in the series. So if we are suppose we are operating it, we are lifting something, lifting, there will be a limit from where beyond which we cannot lift the load. Or whenever we are lowering, suppose the wire coil, it has finished, so we can't lower beyond that. So it will have a limit switch. So this limit switch will cut off the circuit, and it will stop the lowering and hoisting operation. So guys, I have completed the 90% explanation of this full diagram. What is left is that port and starboard operation, that is this port and starboard operation, and forward and aft operation. This is very simple. You can see once you press this line, this MCP gets energized. This is a closed line. This AX15 is already energized from here, this part. So it's a closed circuit. From here also it is closed circuit. Okay, this is simple explanation. Same with this also. Okay, now I want you guys to comment down, whoever is watching, and if you are very genuinely watching and want to learn, I am sure I need two answers from you guys. First one is a simple one. So the first question is, why there is NC contact of MD1 and MCD2 in MCU line and MCU2 line. Similarly, why there is MCU1 and MCU2 normally close contact in this line. Why this is there, I want to know from you guys. Comment down your answer. And my second question will be the use of this timer TM2. It is, as you can notice, this is there only in the line of MCF and MCA. Whenever there is a forward and aft movement, there is a off delay timer TM2. This is 0.5 second. I want you guys to think about this and guess, imagine, and write down your answer in comment. Why do you think this is there? And this is important. That is why it is there. So if you see, it is not there in the port and starboard operation. If I will just read, it is this thing. Whenever you are doing the port and starboard operation, this MCP and MCS, there is no such timer. But whenever we are doing MCF, forward and aft operation, we have a time delay timer, off delay timer, MCF and MC. And if you guys are able to answer this my question, it is, I'm very good, very happy. You guys are using your mind, you guys doing some imagination. If not, I will make a video on this, but there is a condition. I need at least 50 response from you guys in the comment section about these two questions which I asked. If I get 50 comments at least, so that 50 different users, 50 different students uh, answer this question, then I will be making another video which I will explain the full operation of this two also. It will be a small video. I know this video has been long because I have been trying to explain you guys each and every line very in details, so that you don't miss any part. Why every relay, why this AX15 is there, why MC0, why AX3, why AX0, so many relays are there in this. Why the function of each and every relay I want to explain line by line operation. That is why this video has been long. So I am putting this much effort for you guys. So I want you guys to put little effort, imagine the answer of these two questions, and do comment your answers.